So we've been solving a lot of these problems using relative velocity. And so here's the equation right here. Velocity of B is velocity of A plus B relative to A. And we write in what we know about everything, and we end up with a vector equation, and there's two unknowns. And taking X and Y components, we're able to solve that. Let me close my door. So another way to do this is if you can pick the point A such that the velocity is zero, and so that would mean that this velocity was zero, then the equation just becomes simply rotation about this special point, and it's just omega cross r will be the velocity. And this special point we call instantaneous center. The center because that's what you're rotating about, and instantaneous because it moves around. It's not always in the same spot. Okay, so how do you find this special point, the instantaneous center? And there's three types of problems that you are given. One is, first of all, if you're given the velocity and the omega, and you know that velocity is r times omega, well, the distance away, r, would be the velocity divided by omega. And you know that it's the perpendicular distance. And so the distance r to the instantaneous center will just be v over r, and you can find the point. The second type of problem is you're given 2 points like this, and you're given some velocity directions, like usually a slot or a surface. And then what you do is you draw perpendicular to both of these velocities. There. And wherever these lines intersect, that's your instantaneous center. And if you're good with geometry, you can find all the distances. And the third and final kind of problem is you're given two velocities, but they happen to be parallel. So you try your little trick like number 2, you know, perpendicular to that, and then you draw perpendicular to that one, and lo and behold, the two lines are on each other. They intersect everywhere. You can't find the point. Well, when you have two perpendicular velocities, and two parallel velocities like that, you draw the perpendicular line between the two velocities, and we know that the velocities are proportional to their distance from the instantaneous center. So if you were to just draw a straight line connecting them, this would be the instantaneous center, because now the velocities are proportional to their distances by similar triangles. Here's another one. Let's say you've got a velocity there like this, a velocity there like that. Again, you draw perpendicular. You're like, oh no, it's just a minute. My pencil has run out of battery. Let me record it and recharge it and come back. So you have these two velocities that are parallel to each other, and so you try drawing your dotted lines, and they're on each other. Again, just connect the two ends with a straight line, and right there will be the instantaneous center. And once you find an instantaneous center, you know that the absolute value of the velocity is just r times omega, where you take the perpendicular distance of r will equal the velocity, and you can figure out the directions by looking at which way it's spinning, right-hand rule or counterclockwise, counterclockwise, clockwise or counterclockwise. And so the two classic problems involving instantaneous center is rolling without slipping. In this case, the ground has a velocity of 0. Sometimes it's on a conveyor belt, so the ground does have a velocity. In this case, the instantaneous center, because it's 0 there, is 0. And the other one is if you have some kind of bar, and so in this case, you know, the velocity at any point is just that distance perpendicular times omega is the velocity. And the other type is you have a ladder sliding down a corner or two slots, and so you know the directions of the two ends of the bar or the ladder, and so you draw perpendicular to that. perpendicular to that. And that would be the instantaneous center. Given one of the velocities, you divide by the distance, you can get the omega. They might ask you something like, oh, what's the velocity of the center? Well, you would find that distance r times omega, and try to draw perpendicular to that. That would be the velocity. Anyway, that's instantaneous center, and we'll do some examples, and it'll be clearer, I think, when you see the examples.